Hello, how are you? Hope you're doing well. With me it's a quadratic equation, so let us solve it using factorization method. Okay, so what we need to do here is we need to find the product, sum, and two factors. So a product is a number that we are going to get when we multiply these two and a coefficient of x squared. So when we look at this equation, we have the coefficient of x to be 1 and here we have a 2. So our product is a 2. Product is a 2. Now let us find the sum. So the sum is this number with only x without a square. So our sum is equal to 3. Okay. So now we need to find factors. Okay. So these factors are going to be two numbers that when we multiply them, we get the product. When we add them, we get 3. So these two numbers are 2 and 1. Okay, so you see that when you multiply 2 times 1, we are getting a 2. And when you add 2 plus 1, we are getting a 3. So that is what it means. So from there, let us replace. We are going to say x squared plus 2x plus x plus 2. Okay, so I've just replaced here. So where there's 3, I'm going to put these factors. Okay, but 1 cannot be expressed as 1 because it has an x. So we're going just to say x. Okay, so now let's factorize. So we factor out x here. We're going to say x outside the bracket. Then x into x squared, we remain with 1x plus x into 2x, we remain with 2x will cancel. Then plus. So here we are going to factor out 1. So 1, then open bracket, 1 into x, it's x, then plus 2, then plus, and 2 into 1, 1 into 2, it's a 2. Okay, so we have two same values, that is x plus 2 and x plus 2, but we have also x plus 1. So we're going to say x plus 2 and x plus 1. These are the values. Now, have you ever wondered as to why we always come up with these such values? Okay, so you might be wondering why you are seeing this and this. That is the reason to why we have this. We want to know where this comes from. But before we know where this comes from, let us know how we came about this, how we came up with this equation. So this equation came from this, just what you're seeing here. Okay, let me explain. So this is a square box. So a square box, to find the area of a square box, we are going to say L times B. Okay, so what is L times B? We're just going to say x times x, that is x squared. Okay, you see this is x squared. Then plus. Okay, so we have this x, this rectangle. Okay, two sides are equal and another two sides are equal. So this is a rectangle, right? So we have x and 1 unit here, x 1 unit. So we're just going to say, what is this plus this plus this? After all, we found L times B because we want to find the area of this. Then we make the total of everything, right? So we're going to say x times 1, that is just x. X times 1, it's a 1. It's a x. X times 1, it's a x. So we are going to say x plus x plus x, okay? So from here we're going to say, so this is what is here. So x plus x plus x. So for us to find the value of x plus x, we are going to add the coefficients of each x. So the coefficient of this x is 1, and this one is 1, this one is also 1. So together they are making 3. Okay? 3 of what? 3 coefficients of these x that you are seeing here. So x, then this is equal to a 3x. Okay? Then we have this one without values. Okay? Without letters, or without letters. So this is 1 unit, 1 unit. So 1 by 1 is just a 1, and 1 by 1 is also a 1. So we're going to say 1 times 1, it's a 1, plus 1 times 1, it's also a 1. So 1 plus 1 is equal to a 2. So there we're going to have a 2. That is why we came up with this equation, x squared plus 3x plus 2. You see? So this is where this equation comes from. Alright, so now let us try to understand where this comes from. Okay, so when we put together this box, this, and these two guys here, we are going to come up with this. Okay, it's also a square. It's a square. It might not be a square because when drawing I may not be accurate, but this should be a square. Okay, yeah, so now here what we are going to say, we are going to write the values that we are seeing here around this. Okay, so this square has x, so the distance from here up to here, it's x, and the distance from here up to here, it's a 1. You can see nice there. And also this one, it's a 1. And this one is this one, which is down here. It's also a 1. So even here, it's x. Okay, it's x there. All right. Same applies to this side. This side is also x. And this is 1. Remember, this is a square. We said it is 1 by 1. And also this one is 1 by 1. So we are going to say 1, 1, and 1. This one, it's x. Okay, let us continue. So for us to find the area of this box, of this square box, we are going to say L times B, alright? So for us to find the area, we are supposed to first find the total distance from here up to this side, okay? So the total distance from here up to this side is x plus 1 plus 1, okay? So we're going to say x here plus 1 plus another 1 here. So I've just picked this distance from here up to here plus this one from here up to here plus this one from here up to here as well. Okay, so we are going to conclude and say this is x plus 2, because when we add 1 plus 1 we are getting a 2. So this is the distance from here up to here. Then we also need to find the distance from here up to here. So we're just going to do the same. So x plus 1. So this will be equal to x plus 1. So this is the distance from here up to here. So now we said this is also equal to this, because this is an x and this is 1 1, so we are still going to get x plus 2, and this side also we're still going to get x plus 1. So now let us now find the area. We say the area is this times this, okay? L times B. So L times B, since our L is x plus 1 and our B is x plus 2, so we're just going to say x plus 2 times x plus 1 is our what? Our area. So this is where this value comes from, okay? Hope you're able to understand. This is where this value comes from, okay? Thank you so much. This is the value, and this is how we get this equation factorized. Whenever you come up with such equation, just know that you are somehow, somewhere finding the area of a square box that was illustrated from a quadratic equation. Thank you so much and be blessed.